Hi, my name is Christoph Frank. I'm an acoustic engineer here at Austrian Audio. We recently released a new plugin called the AmbiCreator, and I would like to use this video to show you how it works and especially talk about Ambisonics, as this is a topic important for everybody working in audio now and for sure in the next future. So if you Google Ambisonics, you will most likely find the graph I want to show you. This pyramid graph is overwhelming at first for everybody, I would say, who does not know anything about Ambisonics. You probably see that the top of the pyramid is an omni. So we know this as an omnidirectional microphone, for example. And then we see three figure-of-8 characteristic graphs. And then, a bunch of other stuff, which is the so-called higher order Ambisonics. This graph is, by the way, from a very good book. It's for free. It's called Ambisonics by my dear friends Franz Zotter and Matthias Frank. So make sure to check it out if you want to know more details. I want to talk about first order Ambisonics today. So this is basically omni and figure-of-8 characteristics. So basically think about Ambisonics as a format to produce and to transport, very important, sound recordings from the whole 360-degree area. So not only horizontal plane, also vertical plane. Most of you probably know how a dual membrane microphone works. So I've prepared something for you. I used graphs from a very cool manual, actually, from Josephson's C700 series microphones. So basically this shows, for example, if you take an omnidirectional characteristics and you mix it with a figure-of-8 characteristics, you get a cardioid pattern. I think most of you will know this. If you now don't mix these two characteristics one-to-one, but in different ratios, you can basically do every characteristic we all know, cardioid, supercardioid, hypercardioid. This is essentially what our Polar Pilot app does if you use it with our OC818 microphone. So if we look to a quick demo version, you can actually download the app even if you don't own the product and check it out for yourself. I can now here, by mixing the different characteristics, can get figure-of-8, cardioid, everything in between up to an omnidirectional characteristics. Now, what's maybe not that obvious, but you can also use this to have, for example, a cardioid pattern facing to the rear. So again, from the manual of David Josephson, you can see it here. If I use the omnidirectional pattern and subtract the figure-of-8 from it, I get a cardioid facing to the rear. And we can do all these characteristics, as I said, from a dual diaphragm microphone. And if we now have two dual diaphragm microphones facing 90 degrees to each other, we can actually have a figure-of-8 in the one direction and a figure-of-8 in the other direction. So if we now combine these two together, we actually get a figure-of-8 45 degrees shifted. And with this, you can maybe already guess, we can have a cardioid pattern which can steer around the whole horizontal plane. Now, this is useful for stereo recordings and such, but for Ambisonics, I told you we also want the vertical plane. So now we need to find out how can we have a cardioid pattern facing to the top and to the bottom. For this, we use actually a technique coming from automotive or mobile phones, and this is the so-called end-fire array. So if you have two omnidirectional microphones in a physical distance, so for example, in our microphone array, we have the distance between the two capsules. We can have a figure-of-8 in this vertical plane, in the z-axis facing from the top to the bottom. What you can see here is that the frequency response of this figure-of-8 will be quite odd, let's say. We can compensate this in our plugin. What's important to know is that there is a band limitation. So the z-axis in our program, in our plugin, will work up to, let's say, around 2 kilohertz. But there are many cues in this frequency band, like voices, different sounds, percussive sounds sometimes. And this makes it very useful to have really this vertical plane. What I will show you now is how a simulated hypercardioid looks like from our OC818 array with the AmbiCreator, steering around the vertical plane. It's at 1 kilohertz and it's a simulated hypercardioid. So you can see that it's really looking like a nice hypercardioid throughout the whole vertical plane. It can listen, let's say, upwards, it can listen downwards. So now if we talk about Ambisonics, it's also important to know that this is a transportation format. Because, you know, in stereo recordings, for example, you have a 2-channel recording, left channel, right channel. Channel 1 is left, channel 2 is right. Quite obvious. For Ambisonics, it's a little bit more difficult. I want to talk about this now. So here you see, again, the top of the pyramid, the Ambisonics pyramid we have looked on to before. But now the signals are named differently. So we have a W signal, which is the omni, and we have 3 figure of 8s called X, Z, and Y, basically naming the axis on which they are achieved. And if you had to do with Ambisonics, you will probably know these 2 terms. It's MBX and FUMA. And they basically define in which order these 4 signals are presented. So for MBX, it's W, Y, Z, and X. And for FUMA, it's W, X, Y, and Z. That's almost all of it. So it's just in which order these channels are presented. Important to know because some DAWs use different orders. Most of them use MBX these days. Our plugin can output both. So now if we want to use Ambisonics, which is a really spatial information, we somehow need to represent it to the user. If you have these 4 channels in the right format, you can do a mono signal out of it, which is not really useful at all. You can do a stereo signal out of it, which also is not so useful as you could then have already recorded in stereo. But here comes the interesting thing. You can now do from these 4 channels, for example, a 5.1 recording, where it's basically simulating a cardioid looking to the left, or from your face, this side, left side, right side, center, rear, right, and left rear. And you can get this 5.1 signal out of it. It can be 7.1 and so on. This would all be the horizontal plane. As we have Ambisonics with the Z channel, we can also do newer formats like, for example, the Dolby Atmos. So anything coming from the top, like these top loudspeakers. Most users probably don't have a Dolby Atmos system at their home. So here is another way to represent Ambisonics, and this is headphones. Headphones, of course, only have 2 drivers, like our HiX50 and HiX55, 2 very good drivers, left and right side, but these are static drivers. They cannot move. They cannot really simulate sound coming from the front or from the back. So what is used for this is the HRTFs. HRTFs, or head-related transfer functions, are basically functions which define how the sound travels to your ear. So if you, for example, like in this graph, have a sound source at the right side, the sound will travel to your right ear and it will travel to your left ear, and with different transmissions. So now think about it this way. We can simulate with our Ambisonics signal, done by our Ambisonics array, a cardioid pattern facing to the right side, and we can put this head-related transfer function onto the signal as if the sound would come from this side and simulate it to your ear. We can do the same to the left side, rear side, top and bottom too, as we have the Z-axis. These head-related transfer functions are actually very depending on your physical ear, so really what your ear looks like. Nevertheless, some standards have established. There's, for example, a set of YouTube HRTFs, which YouTube is using. Different ones will probably work differently for different people. A plugin I like to use is the Binaural Decoder by the IEM, which is the Institute of Electronic Music in Graz. It's for free, and it does a lot of more tricks actually to have a very good spatial impression coming from an Ambisonic signal via headphones. Make sure to download it. It's for free, included in the IEM plugin suite. If you use our AmbiCreator plugin in your DAW, like I do here in Cubase, you need to make sure you have the right recording. In our plugin, there is a sketch showing you how you need to configure your in and outputs when you use it with your OC818 microphone. You need to use our OC818 microphone in the dual mode, where we can record the front-facing diaphragm and the back-facing diaphragm separately. So make sure the main XLR, which is the front output, goes to your first input, and the rear goes to your second input, and then 3 and 4 for the upper microphone, which is 90-degree angled to the lower one. I have here a recording of a flute and a clarinet, which I quickly want to play. So you can see the level meters in our plugin showing you the in and output. Let me stop here for a second. On the left side you see really the raw microphone signals, which is front, back, left and right. And on the other side you see the output. In this case MBX is selected, so you have W, Y, Z, X. You can also switch to FUMA if you want, and then you have W, X, Y, Z. The other things you can configure in the plugin is gain adjustment, so you can add up to 10 dB gain or decrease the gain. This is maybe important for some, as you can here use the Z-axis on its own, or you can mix it on its own. So that means if I have 0 dB gain, I have a normal representation also of the Z-axis. I can also decrease it completely if I just want the horizontal plane, or if I have the feeling I need more height information, I can boost it a little bit too. Last but not least, you have here a rotation function. That means, for example, you faced left to the source or right to the source and your source was actually on another direction. You can virtually turn the whole array by up to plus and minus 180 degrees to make sure it's at the right position in your field. You have two possibilities to do this, for example, here in Cubase, to set up your outputs. So if you route your Ambisonic channel with our plugin to your stereo output, if you mix on headphones, for example, you will automatically have the possibility here to use head-related transfer functions, like the standard HRTFs or YouTube HRTFs. If you want to use, for example, the IEM Binaural Decoder, like I like to do it, you need to route your Ambisonics output to an Ambisonics bus and can then use here the Binaural Decoder. And you also get a stereo representation of the signal. So have fun with our plugin and make sure to record in Ambisonics. It's worth a try.